and
In case someone
at a low cost. So the agenda, I will give a brief introduction from a Saab perspective. Then we will talk about the technologies we have used to enable federation of PLM systems, and just to make sure PLM product lifecycle management. And then the third bullet is where we hope to see a lot of interaction. What are the needs? What experiences can we share? And then we'll try to summarize, and we will end at
is it 2 hours?
2 hours. So that would, I was just trying to do, this was 1:30, so it will be 3:30. You just have to do the time conversion. Because somehow the UK people or the British speaking people do everything wrong. Why can't you all speak Swedish? So that's the agenda. Well, we ran a project called Hello. Heterogeneous linked product lifecycle environment. That's the second iteration. Some very Swedish companies, so Volvo Cars, Eurostat, KTH, World Institute of Technology, IBM, and Linksworks. And Eurostat is Judith, and Linksworks is Jack. There'll be some co-presenters, and they are the people who know things. I'm just standing here to take some time. And Saab Aeronautics. We are located in Sweden, in Linköping, the aeronautical capital of Sweden. It's very easy because it's just one place where we do the aeronautics. Like all aeronautical industries, we have lots of old offices, but they are very nice if you like the interior in the 1970s. We do the Gripen, we do the Global Eye, some parts of the T7, the things that make sure that Boeing can attach the wings, basically. And our life has changed. We used to be the Swedish provider of jet fighters, but nowadays we are international. We have multiple projects running in parallel. We do lots of exports. The Global Eye is supposed to sell to the UAE and not to Sweden. Very much international collaboration. And we also know that the international rules are becoming more and more stringent. Speed is more and more important, both in product development, but also in the development and maintenance of our enabling systems. And just to do a very quick check, how many of your organizations here are still using DOS Classic? It was simply the best 2000, but it's not the best today, but we're stuck. So our need is really to, how can we make sure that our enabling systems are keeping track with the development externally, so we can exchange them very quickly. And if we look at our organizations again, if we want to be competitive, we need to always align with international best practice. Since we don't know very much about our future, especially since Russia's invasion of Ukraine, we have to be very flexible. We don't know what's coming next. So that means we need to optimize our overall capability. We have to have the capability to adapt very quickly. And also when we get into new collaborations, we should be able to adapt to the special needs of that collaboration. And it can't be expensive. And we must be able to do it very quickly. So when we realized these were our problems, we sat down and thought a little bit and compared our different engineering processes for systems engineering, mechanical engineering, software engineering, and essentially they're all the same. You do some requirements, then there's architecture and design, you implement stuff, you verify, validate, and finally declare that you're ready. The software process, systems engineering process, they're all the same. So what if we could create the development environment where we optimized the environment for each engineering discipline. So we could give our systems engineers the best of breed, software engineers as well. And if we do that, of course, we need to maintain traceability. So we need to maintain requirements traceability. We have to have the ability to build a product structure. We have to keep track of changes and also all this been realized. And this structure might be very specific to Saab, and maybe it would be different in another organization. And traceability is mainly in those directions, and we know that we need an archive. So maybe if we try to structure our development environment this way, what would we have? Well, first of all, we would have modularity. So we could exchange the individual environments quite easily, especially in software where development is so quick. So if we get into a new collaboration, a new project, wouldn't it be nice to take the latest and best software engineering and replace it, the old one? And also, if we have this modularity, very much of the migration pain will go away, because you are not migrating your whole PLM system, you're just migrating what you're migrating a domain or a discipline. And the other thing we want to do, and that is very clear, is that in modern development environments, everybody meets. In our past in the development environments, we had the engineers in the actual environment, these configuration management people, they were in the PLM system, and the project managers were in PowerPoint. But if we could make them all meet and work and look at actual data. But as you can see, this means that we have to accept redundant capabilities, because the systems engineers, they do requirements, as do the software and mechanical. But we believe it's better to give them something that is specialized for the individual discipline. So we get a good mechanical engineering requirements management too, and a good systems. So traceability is the key to implement this model. And that is why we are very interested in the OSLC standard, and why we have done our implementations. We have 4 dimensions of traceability: requirements, the config structure, change management, and realization. But the important thing here is, of course, that the linkages we make, they must be configuration aware. It's not just to the latest and greatest version. So we have to have the capability to link to the right. And there is where OSLC comes in. And we, in our project, we defined 4 success criteria. So we say federated PLM using OSLC is successful if we can show that it works from a technical perspective, if we can show that the engineers using it are still productive, or as much as productive as if they would have been in a single environment. They should be able to maintain it operationally over time. And finally, it must be cost efficient to implement the interfaces so that we can actually increase, add new tool capabilities, or remove a complete environment and replace it with another. So keep these 4 criteria in mind while you're listening to the people who knows anything, and then we'll see in the end if we agree with me. So I hand over to Jack first.
Yes. Is it really my next? No, for you, I guess.
No, you change presentation. Your presentation.
Those are the people who prepare.
Ah, I changed presentation,
Yeah.
yes. Sorry, we switch, you mean
Yes.
files?
Yes.
Then maybe I could.
Yes.
Yes.
What about the service and the complete life cycle of the things that you develop now, it seems to be focused more on the development
Yes,
side.
it's, if you remember the hardware
Mm.
thing. It is as long as software and systems engineering, but the hardware arrow is a lot longer. Because that
okay.
is what is being serviced and
Mm.
maintained over time.
So it's a whole life cycle.
Yeah.
Product life cycle.
So, but if we had drawn a picture that way, it wouldn't have been that attractive.
Okay, so I thought this, or should I change this title, because I thought I'd give an introduction to OSSE. Just at least from people in the room, how many are familiar with OSSE? Okay, good. At least someone will get that. So this is a very non-technical way, the way I choose to present OSSE without saying the word.
In 2 minutes.
In 2 minutes. Yes, I normally speak fast, so please just interrupt me so it takes longer. Yeah. So if you have, this is a typical heterogeneous system. I just put some names of icons of applications. I hope you can recognize one or two of them, but this is typically how you have your environment. And if you want to do an integration, let's say you have requirements in, let me point at the screen also. So, you know, if you have requirements in Polarion and you have your tasks in Jira, and then you want to have this answer to this question, okay, which tasks in this Jira are implemented by this requirement? How do you normally typically solve that problem? If you give that question to the IT, if you want to do an integration, typically what you would do is you will create some sort of synchronization job. You copy all the Jira tasks into Polarion. You try to interpret what they mean, etc. And then you make that connection internally within Polarion. So you have some sort of import export kind of synchronization. And then, you know, you do a query within Polarion to get an answer to that question. And this is like the cheapest, most effective way of doing an integration, just point to point. And normally point to point is very efficient, but it's sort of frowned upon when it comes to integration because for the following reasons. Imagine that same kind of questions you want to do in other applications, you know, MATLAB Simulink, for example, or IBM doors. Then you need to do that same job again. You synchronize the information, export it from Jira into that, and do your own interpretation of it there, etc. So you're doing the job 4 times. It's a problem when it comes to scalability. You might lead to inconsistencies because it's the IBM people trying, like IBM doors, I should say, the user of that trying to interpret the Jira data. So you're in the wrong domain. So you might have another understanding of what the Jira data is compared to Polarion. So all of a sudden you have 2 representations of actually 3 representations of the same information. And you're doing a tight coupling with it. The data here, if that structure changes, then you need to update all your transformations. And finally, you have this master data kind of issue. If the Jira information that went to MATLAB, you did another integration, all of a sudden you have Jira issue that you don't really know where it comes from in different versions of it. This is how you end up with inconsistent copies of the same information. And this is why we don't like point to point, but this is what I call consume. So these presentations, by the way, is my way of representing OSSE. It's not the OSSE official terms yet. Okay. So this is what I call consumer based, because every consumer is trying to take that information and doing their own interpretation of the data. Instead, imagine doing that. Let the owner of the information, if you're responsible for the product data in Jira, if you do that representation, you filter the information in Jira to only show consumers potentially what they should see in a very structured way, so it's very understandable. And then any consumer can just grab that information. You're doing that transformation once. It's very clean. It's very understandable. It's still point to point in the sense that consumers can directly go to the source of Jira information and grabbing it. You don't need to go through these centralized platforms or middleware or something to do that. You can still have that. It's not an exclusive, but there's no need for that. You can still filter the information and clean it at the source and make everything available, make it available to all consumers. So you just share the information as the owner of the product data defines it as it is. And the other picture here is that we're putting an internet box. Imagine that every application is actually a web server. So you use the internet kind of technology, web services, microservices, that kind of technology to share that information. Because the data then becomes available, 24/7 with basic REST APIs. So basically what we're saying is in front of every application, put a web application. Standard technologies like REST is very popular. There's nothing controversial there. And clean up the data so it's available in a very consistent way, the way you think as an owner of the data. Just filter it and present it the way you think it should be represented. So no one needs to do that kind of guessing of what the data is. And that's pretty much the idea of OSSE behind it. let's borrow the architecture of the internet. And this sounds maybe trivial for some applications. They are already web-based, but many applications are not. MATLAB Simulink, for example, is files-based. So even if it is, maybe we can represent the data as web services. We standardize the interfaces. So if you have a tool for Polarion handles requirements, for example, Doors handles requirements. If we agree on what a requirement object should look like at the minimum, then it doesn't really matter as a consumer whether you're reading data from Polarion or Doors. You're going to see it as a requirement. And OSSC uses this really nice technology where when you grab the data, a machine is going to actually understand, this is actually a requirement object. It's got the semantics and the meaning of the data in the actual data itself, without going into a lot of detail. So you can really identify what kind of data you're looking at while looking at it also. And then another philosophy we've had is this just enough integration. So keep the data minimal. So the minimum, OSSC has been minimalistic in the way they define, again, for example, requirements. It must have a name, a description, an assignee, creation date, that kind of thing. But we didn't go into the bigger detail of specifying everything, but every application can extend that into more specific attributes, etc. But the idea is to keep the domain model as minimal as possible to make it maintainable over time. So this is a little bit of the OSSC approach. This is another way, again, let's say basic principles that you can apply, even if you don't want to go all the way with the OSSC technology. But if you think of it as just some basic principles that you can apply, you don't have to have OSSC. I mean, OSSC can sound like something you have to strategically agree that all your tool chain should apply. But these are principles. If you're doing this point-to-point integration I talked about at the start with two applications, maybe you can already benefit from an OSSC approach by using these. The most basic one is put a web service in front of your application. Make it available 24/7. Because that will, I mean, if I take MATLAB Simulink as my favorite example, these are files. It's very expensive to find where they are, to try to read it, interpret it, try to guess what it means. If the owner of these models can do a web service in front of it and make the data available 24/7, you don't need to do that guesswork of where the files are, how should I interpret them, etc. So it sounds like, I would say every application should do this out of the box, but unfortunately we're not there yet. So just doing that web service up front you will save a lot of effort, because it also means people don't need to copy the information anymore. They can just connect to it. It's there. You don't need to read it and guess and keep a copy of it, performance-wise, caching, etc. Provide the model according to a domain model would be the second level. Many applications will have a very generic API because, I mean, if you have Atlassian Jira, they have an API that applies for any kind of end user. So it's very generic. You get hundreds of fields per item. But for your particular application in your organization, you need a minimal set of that. So you need to build your own domain model on top of the application's domain model to minimize, again, what kind of information and make it consistent with the semantics of your own application and your own organization. This is a concept of sharing with global ID. So all these objects that you're sharing from the different applications, if they all have a unique ID, and by that we actually mean a URL. So what you want is an ID where it's unique, so you know what the object is, and it's not going to be in common, but that could be a GUID or any kind of ID. But imagine instead you have a URL for every item in your system. And what a URL is not only an ID, but also it's a location of where the data comes from. So you can always do a get on that and get the latest information from the system itself. So even when you synchronize data and that object moves around, you can always find its ID. And when you literally on the web, you can just do a URL get on that, and you will know exactly where it came from with the latest information from that. So yeah, that's a simple, I think it's a very powerful thing with OSSC that they use URLs for applications. One confusion you have with that is that it doesn't mean that your application must use URLs internally. You can have global, like local IDs or whatever, but when you share information, give a global URL for your application, for every item you have. Because even when it moves around, you always go back and you avoid this master data management issue by always going back to the source with the use of that URL. OSSC have this idea, I will show you a demo of it. So the integration is not only for the machines, it's not only an API call to get JSON or XML from it. You can also integrate, I will give a demo on that. You actually help the engineers make that traceability by doing embedding of the URL. So we're doing integration for the end users. That will be best explained with a demo. This is something also you can start thinking about. I think these are the two key things with OSSC. And finally, you need some sort of governance. So even these domain models, every application would have its domain model, but an article can exist in many, information about an article can exist in many applications. So there is an overlap on these domain models in the different applications. So you need some sort of coordination of these different domain models and how they work together, some sort of governance of data, of your data model, actually.
So
Yeah.
what do you mean?
Yes.
Clarify what you're distinguishing there between the global aspect and the local aspect.
So what the way I see it is that for every data, I mean, if you're the product owner for Jira data, maybe you should be able to define your own domain model for that data without having a central. We've been in projects where you have these mega information models where everyone has to agree on everything. And that's sort of just never ends kind of project. So instead, if you own the data, you should be able to define how the data should look like on your interface. But then you might, so everyone does it locally. That's the federation part. But then there is an interaction point with the others, right? So you might have something to do with change requests, and other systems might call something change request. So you might want to coordinate that. And that should be more a centralized role to control that coordination.
Okay, I think I know what you mean.
Yeah.
I agree, I think I agree. It's a weird phrasing.
Okay, I would be happy with feedback on that, how we can term it. But that's the idea with, I mean, here at the level 2, I was thinking of a local model. And then somehow you need to coordinate it in a centralized role or centralized government, some sort of governance body or something.
Yeah, not to get too far ahead of this.
Yeah.
So the URLs in SysML and UML use UIDs, which do effectively the same thing.
Yeah.
Unique thing. This is proving to be a dead end.
With UIDs.
Yeah,
Yeah.
because the problem is you make an aircraft, and this year we use General Electric's jet engine, and we put 7,000 links into UIDs inside the jet engine. Next year's aircraft, we want to switch out and use a Rolls-Royce jet engine. And now you've got to tear it all apart and redo it. And this seems to have, so what's going on in the OSLC? It seems to be exactly the same dead end if you tie everything together with fixed point URLs instead of ID keys where you could say, all right, jet engine manufacturer, you've got to supply this, and this.
Yeah, but the UID is just a string, right? So it doesn't, that will be
Yeah, well,
internally how
it's
you map.
globally unique, and so it's the same motivation.
Globally unique,
Yeah,
but you,
but that, I think the difference if you are in SysML, for instance, you will have a UID, which is unique within your toolset.
exactly.
And the OSLC approach is to have a globally unique identifier based on your URI. And then whether you use, I mean, how to effectively replace one engine with another, that's not, I mean, it's not solved by OSLC. You have to think further to do that. But the thing is, your UID is no longer unique only within your own environment. It's a globally unique.
Right. So this problem of globally unique is actually a topology problem. And I know this from IBM. IBM was contributing a lot of what's XML came out of the SPML, which came out of IBM publishing systems where they wrote encyclopedias for mainframes. And when they started to make modular text, they wanted to make text units that could go into a website, into a manual, into the online help. And they found it worked great, except for cross-references.
Yeah.
Cross-references, permanent cross-references killed it.
Yeah.
And so in that community, what they learned to do was link to a well-defined external ID and then have a linker that would assemble and resolve the links in context of your project. So if you were making the manual, it would resolve to a page number.
Yeah.
If you were putting together a website, it would resolve to the right web page and so on. So this topic comes over and over and over and over and over. The permanent link sounds really sad. It's like, oh my God, it's permanent. It will never go away, but it actually causes a lot of trouble.
Yeah.
In-
I mean, it depends on how you use it,
Yeah,
I should say, because you can still have permanent links, but you have the resolver outside.
or resolver right
Yeah.
outside that. Yeah, so now it's not really truly, if you're linking to that can be resolved to different things, it's not truly globally unique again. So you're now going to, which is what I want, by the way. I want to have a set of permanent IDs for the jet engine attributes and then resolve to the right jet engine when I put the jet engine in.
Well, when you say the word resolve, I mean, it reminds me of the word.
You want both.
Yeah.
Exactly.
Yeah, you really want both because
Mhm.
you need also to know when you know, you look at it again the next time, you're actually pointing to a different object and you have to re-perform analysis.
Yeah, well, you
again,
want to
right?
be aware of it, right? Yeah.
Right,
So part of this is,
Bring in mind,
Mhm.
because this is the traceability of the configuration management of traceability,
Yeah.
which is resolved very nicely within OSLC.
Mhm.
But we'll come to that.
Yeah.
But none of this depends on OSLC that you.
yeah, so this is actually where because this is actually my own pitch of OSSC, because when I go to OSSC, it's a standard and people, it's a standard, we don't want to apply it. So the way I put it here is just, you can do this without any OSSC, but that's what OSSC is also. So, and you can do it again with just your next integration, your
But
next
it could
point
be
of
hybrid
just
as
go for it.
well, where some might be OSLC connected.
But why reinvent the wheel when someone has done such a great job? Why don't you then go to OSSC and borrow that technology? It's already these 8 things.
There might be other limitations.
Sorry?
There might be other limitations.
Yeah, exactly, yeah. So yeah, go ahead and do that. This is actually a little bit my,
Yeah, so the motivations are really good, but
Yeah.
there are some problems with the permanent.
yeah. I mean, permanence, in my view, if things disappears, no one's gonna solve that. So when it comes to objects being permanent or items being permanent, that you have to solve for that.
Yeah.
What OSSC does is, it's not only an ID, where you say you are like an identifier, but it's also a locator, and that's the resolving part. You know where to go to grab it.
Right.
If it's not there, there's no one gonna solve that, right? If it disappears, it disappears. That's
Yeah.
no one's gonna help you with that.
Mm.
But what I think can help is that you can hide, even if you switch something else, if the public URL is a locator, you can remove one system, put another one. As long as you're resolving it in the right way, no one's gonna find out. So I can switch one requirement store with another. I mean, sounds naive, but at least you have a chance of doing it.
Yeah.
If you hide the internal UID from the external global URL.
Yeah, that's not as severe. That's actually more tractable than UUIDs, which are supposed to be in the entire universe, totally
It's-
unique.
yeah. But, URLs are globally unique in the universe.
Yeah, you need to progress in the presentation.
But we
Since-
did a discussion, not this presentation, so this is good.
Yeah, but
We have to out.
John, maybe.
Yes.
Well, it seems like, again, there are two purposes here.
Yeah.
We need to be able to trace from specific requirements to specific features.
Yes.
That satisfy that. requirement.
Yes,
As well as generically, requirements trace to features, and they trace maybe differently with electrical feature versus a structural feature versus some other feature. But we got to be able to show the specific.
Yeah.
connectivity.
which leads me to my demonstration of how you can do traceability. Okay, am I taking too much time?
No.
Yeah, okay. So just to show you how OSSC works in practice, this is a setup. Yep. So imagine you have like 5 functions. You have requirements, and you know what we showed in the style model. Your requirements are actually the system requirements are in doors next, but the hardware requirements are in shared space. Just as an example, you're doing the verification, the validation, the testing. You're doing it in Polarium. The planning is done in Jira, and you're keeping your system of records in Polarium. It just happens to be the case. You can always argue why, but this is the setup. So how would you deal with this? This is your setup. And imagine this very simple scenario. Imagine comes a change request. Someone wanted something, a customer, and that led to the fact that you need a new requirement. You write that in, what did I say, doors? Yeah. And then someone needs to write the test cases. They need to write it in Polarium for these requirements. And then you're gonna be able to create traceability links from the test cases to requirements. And this is what I will show you. This is like a need. And then once you're done, you do the change, then you create this change notice. You create the change notice in Polarium, I think. And then you want to create traceability links to the original change request, which happens to be Jira. This is just 2 scenarios of traceability, just to show you. And I will do is I'll just show it to you live, because I think it's more risky. How does that work now? We made the mix here. How would they see? Why don't you see my screen? Oh, you do see my screen.
Yeah.
Yes, sorry. Okay, this is confused. So this is doors. These are your requirements. This is my test cases. This is in Polarium. These are just objects. Maybe you're not familiar. I guess you're not familiar with Polarium. These are your different test cases. So the user writes a test case, and now they want to make a connection to the requirement. So what you do is you do edit link. And this is just standard Polarium functionality. And you say, look, I want to be able to verify And typically what you do is, you click here, and then you're gonna choose a requirement within Polarion. This is just the standard way you choose a requirement and connect to it. But what I wanna do in this case is, I know that I wanna connect to outside. So you see this thing, internet thing was enabled when I chose verify. Because Polarion knows that, requirements can also exist outside of my system. So you click on that, then Polarion goes and finds doors Next.js. I've configured the project to do that. And then I say, I want to connect to a requirement. Now, what Polarion does here is just simply stupidly just gives a frame for doors to say, look, let the user search and do the thing indoors and get back to me with the item they choose. So all this functionality here is a doors native window. The user will do the magic they need to do to find the requirement. They can browse and search. They say, okay, this is my requirement. And then they press OK. As soon as they press OK, the only thing Polarion receives from here is just the URL of that item. So Polarion didn't have to do the query to get the data, to do the search, to represent it. That's all delegated to IBM doors. And then they just get back a URL. And then you've made a connection to the item indoors. Use that URL. If the user wants to, here it is. Now imagine me or any other user that logs in, this is a link to doors, they just hover over it. And then again, Polarion doesn't have any of that information. They just ask doors, give me a representation for the end user to represent this information. So you haven't done any synchronization of the work. You didn't have to interpret, Polarion doesn't have to do any interpretation of this information. They just say represent it, and then IBM does that representation. And this is what we mean by helping the integration for the end user. The end user can work in both systems and they can make traceability without synchronizing any data. And no deal of syncing even the semantics of it. Yeah, this is one case. And then if you just another case quickly, you can be in, this is your change notices, and you can do the same thing. And I think it's worth doing it. I want to be able to connect to my change request. And here it appears. Again, it's the same functionality, but now I want to connect to Jira. So now I get this window from Jira, but I'm not logged into Jira because I need access because it's not Polarion doing it. So I need to actually log into the system. That wasn't intended, but I guess it shows you the point that Polarion is not doing anything. They're just delegating this kind of functionality to the user. So I need to use my JAD's own authentication to get access to this data. And then this could be improved from Polarion's side, but you just need to do it again. And then now I get this information and I can search again. This is from Jira to search and replace. I can do whatever I want here, filter, etc. And then when I find what I want, I do that. And then I give back just the URL for Polarion. And again, when I hover over it, I get a representation of that information. So it's very, very loose connection between the systems. And that same iframe you saw, that could be embedded in any application. So you do the implementation once, and any consumer can embed these doors or Jira queries and stuff in their applications if they're web-based.
Few questions.
Yes,
First of all, those links are now managed by Polarion, right?
those,
Those links that you just created.
yes, the link is owned by.
There is no like central link repository.
No.
Right. So what happens if you confirm, you close it, and I log in,
Yes,
but I don't have access to Jira?
yes. What you will do, the link is there, so we can, I don't have the time to show it to you, but we can do it offline. It's gonna show login. You're gonna try to log in, and if you have access, you're gonna see it. If you can't even log in, you're not gonna be able to
Okay,
log
so I'm
in.
gonna see the URL, but if I hover over it, it's not gonna show me the definition of that
No,
change request.
no.
Correct.
Right.
Yeah, the only problem, and which is beautiful because you're keeping access control, right?
Yeah.
No, the problem with synchronization is that you lose that. The only problem is licenses. You need a license to access the information. So it could be quite expensive to get every user to get license to see that information. That's the one downside.
I mean, there's pros and cons as well, right? I mean, the benefit of synchronizing the information is that you don't have to if you keep making those links.
Yeah.
I have to now log into 15 different applications to see the full definition of the test case, right?
Exactly. Yeah,
And the other thing also, if I'm in Jira and I want to now promote that change object, I have no idea that it's linked to some place that somebody's using it and maybe it's not done with their work, right? There is no bidirectional.
exactly. Well, actually there is. So what Polarion does, that's an implementation is, every time when I create this, Polarion will send a backlink, re-edit, then they will they will notify that, they will send a update request on that one. Says, look, I've linked to you and this is my link. And then you can
Okay,
choose to do
so
it.
Jira gets notified that a link was created to it.
Well, here's the source, so you can do it. The problem with backlinks is that you're duplicating, so you need to update that. If that gets deleted, you also have to update. So there's that problem. There's always pros and cons.
Yeah.
So each side is keeping some record of the existence of the link that was just created.
Can, does not.
So IBM implemented did that until configuration management came into the game, because that backlink, I don't know that technology, like the reason, but that just didn't work when you have configuration management. You will talk about these things. So what they're doing now is instead of doing backlink, Jira what can do is always ask, okay, who's connecting to me, and get that information. Performance wise, it's not a problem because you're getting that information from, if you're getting it from one or two systems, it's not going to be, I mean, you're still getting the information.
Yeah.
Whether it's
You
called
need to
employee
know
or
where to search for those links, right?
yeah, searches, that's where Polaris is doing a query for that. Yeah.
Now, I mean, on the Jira side, like if I'm in Jira and I want to know who's using my change request, now I have
Yeah.
to query each system to know whether they have links.
So that's the latest change in the OSSC. So I'm the co-editor of OSSC. So the latest effort we're doing is that to actually have a service that you can ask, and that service will collect information from the multiple systems to keep that up there. So you only have to ask one place to say, okay, who from all these systems are connecting to me? And
Then you're going back to a centralized service.
for that service, yeah. So federation doesn't mean everything, nothing is central. I mean, requirements are centralized in one system. It's just that requirements are centralized, not like everything is regular. So there's nothing wrong with centralized services for particular functionality in a federated
So I
approach.
had the impression that IBM has implemented that service already, but I couldn't find any description on their website.
It's probably the way they do it internally, and now they're like making it part of the standard.
Mhm.
So I'm sure that's yeah, I'm pretty sure they've already implemented it their way.
Yeah.
No.
But I want to go back to the license question you brought up, Alex, and that is,
I mentioned that.
Well, it's not just license, it's also access, right?
yeah,
Yeah.
but and that is why you want, if you go back to the model I started off with, is that most of the linkages that a systems engineer is doing will be in the systems engineering domain.
Mm.
So they naturally will have access, but there will be a few linkages to other domains. So maybe we will have systems engineers that occasionally access the mechanical and hardware side or software side, but it's not the majority.
I don't know about that, really. I mean, because it's the implementation of the architecture that we're concerned with. It's the item that is being verified.
It's the item that is being verified, software item on its own, but then it's integrated to something else, to an assembly, and then it's verified in the system environment. That's the way we think. So,
That's for the Saab architecture.
yeah, that's the soft architecture. So it depends on the corporate thinking.
The licenses, this is a tool supplier question. I mean, the tool suppliers could offer read-only licenses.
Exactly.
Yeah.
Cheaper or free.
Cheaper or free for this purpose if they wanted to. This has always been a headache.
Yeah.
They sort of done it and then quite, not quite. And,
Yeah.
yeah.
Again, IBM does it, but not everyone.
Mhm.
The other take is you can, I mean, for whatever reason, you can still copy that information if that's what you want for access control, but at least keep that URL. So at least you can get an update of it, or at least know where the master data is. So if you can do this kind of copying sync thing for master data, sorry, for caching, performance, licensing, right? That's fine. Just keep that URL so you know where it came from. So there are ways around it, the pure OSSC way, without contradicting.
Just a question from online visitors. How does it work? You have now the URL. Polari knows about the URL, but when does it sync the content so that they can view it here? Is it really just by the mouse hover event, or is it
Yes.
cached at the beginning when you load the page?
The only thing that is cached is the label. But it literally, this window is coming from the system, from the external, this is coming from Jira. This one
So
here.
each time mouse hover means a query to the
Yes.
other system. Wow,
Yes.
okay.
Yes. Exactly.
And you might say that this is slow, and that's because we are using very low spec service.
Oh, no, it's because the Wi-Fi.
And the Wi-Fi, et cetera. But
Yeah.
if you are in a corporate environment with fully spec service, This is really.
But it's even with that, Eric, if I may, I mean, one Polarian could easily cache that. I mean, when I go twice here, they can easily just cache it, right? Now they literally do it, you can see it on the thing.
But
They can easily locally cache it for me as a browser technology. Two, I forgot the second one. No, I mean, even if this was to be within Polarian, it's still a call to a server. So it's not worse whether it's going to that server or this server.
And you don't want to cache it in Polarium, because if another user looks at it, they may not have the access
still
rights
use it.
to look at the
Yeah.
data on the other
But
side.
they could use it, cache it for that user for the first.
Well,
time.
yes, yeah, the browser can to do
So-
something, but.
So what about queries that go multiple hops?
No, but okay, so this is actually, let's look at here if you have any. This could be, look, if you look at this view, you can look at the module, you can click on it, but you can't hover over that. I think it's just an interface. It will be a challenge, I think. But if you click
If
here,
picked
you end up
one that
going
had
there.
the link to somewhere else, you would see.
Yeah, that's the one, the module here.
No, I mean, if you picked a requirement that had.
This is the requirement, and
Yeah,
I have
but
a link to the module. It's in.
Yeah.
So in-
No, but if you picked a requirement that had a link on it, you would see it on the show.
Oh, okay, you have shown what open here also.
Yeah.
But yeah, you're right. And then the other one, if you want to have questions, I mean, if you want to do queries in Polarion, I can query everything in Polarion. But if I want to query across my test cases, my requirements, and all the information indoors, that's not going to happen there. But there in OSSC, there's a TRS, there is a solution, and IBM has implemented as Engineering Insight, or it's called something else now, where you can do this kind of. So actually what they do is they sync all the information, so they collect all these links and everything, and then you can do your queries there. So again, you can always do sync, but you always know where the source is. Yeah.
Okay.
So certain things you cannot do away with. I mean, it doesn't solve all the problems, but yeah. But even in Engineering Insight, when you look at a link, you will get an embedded view from the source. So you have to be just careful of how you use those links and the caching. Yeah. Okay, am I again? I think I'm done here. This is the for your presentation, but I've shown you this.
Ah.
Yes, you switch to you sharing.
Yes.
Is it?
Share.
So this is one case where we didn't talk about configuration management, just a simple OSS system.
Okay, so we'll carry on. Oops, sorry. Okay, so we're now going to get into configuration management. If I could just get this thing to this one. Okay. So this is the second test case. The Pellicle 2 was a lot about the configuration management side of it. So what we're trying to do is do configuration traceability with configuration management across domains that use different configuration management approaches. Okay, so that was the interesting one. So the idea was you pick a requirement in DAWs, which uses explicit style configurations, which are OSC type configurations. I'll come into exactly what I mean. And we're going to select another requirement from ShareSpace, which is using implicit style configurations. And well, I don't think it answers some of your questions about what, we'll get onto this. And we're trying, basically what we're trying to do is get these two things to play nicely. So there's configuration management from the OSLC style, which is explicit, and one we're doing in ShareSpace, which is the implicits from the STEP standards. So we'll come on to those. Okay, first a few bits. Okay, so OSLC configuration management is really targeted. This is my opinion. If you see the little girl there, it's my opinion. It's really about targeted at early life cycle phases, requirements, ALM, that sort of thing. It's explicit configurations, and I just think of it as sort of baselines and branches and things. That's the sort of level. So how does it actually work? So here's some pictures. Basically, the lines of the streams. So what happens is you do some work and you keep changing it. And if you go and ask something from that stream, you just get the latest until you get to you decided to make a baseline. And then you basically put a point in the ground and say, this is the baseline here. And then if you ask baseline for that resource, you'll get the resource at the time that baseline was stored. And then you can carry on and you can merge them and you can branch them and things like that. But basically, I just think of it like sort of think of DevOps and Git and that sort of thing. That's how it it works. It's not quite, but it's, I'm simplifying, but that's the idea. So that's how the sort of OSLC current types of configuration management are working. Now, in STEP world, STEP can do explicit ones, but I'm just going to talk about the implicit types of configuration management. And these are really aimed at sort of PLM onwards, certainly asset management. So this is an illustration of one of the products we deal with, which is the aircraft carrier, and it's just got some numbers there to tell you the sort of thing. And this is continuously changing as you go through its life cycle. So you've got 150,000 unique parts, you've got 300,000 compartments, you've got 2.1 million occurrences of things that all have to be managed and they're all changing all the time. So basically it's continuously changing and you have to plan an actual. And it comes to the comments the gentleman over there was also talking about variance as things go through. Anyway, very briefly how this works. Again, this is similar sort of style of picture. Basically, you can, when you make a link between two objects, you can either explicitly tell it to get me the latest, whatever that means in your domain, or you can link to specific explicit versions. So you can actually say, I'm going to link to that explicit version. But whenever you create a link between two things, you give it an effectivity, i.e. you say this link is valid from this date and optionally to that date. So you can basically, you've got the complete history going backwards of this link going through. The other one we talk about, STEP has lots of different types of effectivity, but I'm just going to concentrate on the two, which is data effectivity and object effectivity. So again, when you create a link between two things, you can say this is only effective for that variant, for example. So you could have multiple variants and you can have different structures. Basically, you can then filter on the structure by date or object, and you'll get the different representation. So I'm just going to give a very quick example of a very simple example. Here's my laptop. I'm starting in January and I've actually got this disk installed on my laptop. I've got a start date and it's still there, so I haven't got an end date. I then come along and I'm actually going to plan in March. I say at the end of April, I'm going to put a new disk in. I'm planning to put a new disk in. So I've got another relationship to a new disk planned to start on that day. I then come along, actually, it was a bit late, okay? And what happened is in June, I actually removed the old one and put the new one. So you can see the timeline for the old relationship's finished and the new one has started, okay? And so you've got three relationships, actual, plan, actual, between on the date. And as you roll back through your time, you can see, okay, tell me what the date is here, and then you can change the time and you can see that date. And this is actual, I've asked the actual representation or the planned representation. So you can go through, and because all the information there, every relationship's got these dated effectivities on it, you can actually roll back in time and you can see what the structure was at each one. Okay. Perfect. So, right. So I'm just going to very quickly try and show you with this live, if I can get the machine up. So this is what we put into ShareSpace. So I've got this requirement which has got 4 children in it. They all happen to be generated, I think, in about February. I put those children on. So if I come up here and I say, whoops, if I explicitly say, go and give me this date in January sometime, and I say this, basically they disappear because I created them, excuse me, I created them all on the same day. Okay, so now I've rolled back my requirement structure to that particular date and it's disappeared. Okay, so back to the slides. Right. So now I'm going to go on to object effectivity. So this is where your variants and things come in. Same problem. Okay, so I've got my date, got my disk in there that started at this particular date. Now, I'm actually planning to put a new variant in from this date. So my old variant is still there, but I'm planning a second variant that's that, or maybe it's the deluxe version, the super speedy or the, you know, the gaming version or something. And I put this new variant in here. I plan to do that. I come along here, and I put the end date here is created on this first one. And now I've got two variants going forward. I've got from the same date, I've got variant 1 and variant 2 with their relationships. So they've both got a start date and they've now got an object as well, that date at the same time. So, and as you go through, so, oops, sorry, page up. So we start off, if you ask for the blue variant in February, you'll see this. If you ask for the yellow variant in February, you'll see the same thing. Oops, sorry. And then as you go forward, same thing there. But as you come in here, if you ask for the blue one, you'll see that. And if you ask for the yellow one, you'll see that. And that's how the object effectivity works on the relationship. So it's a completely different philosophy from baselines and configurations. And they're aimed at completely two different parts of your life cycle. So if you're trying to manage, you know, the ship in real life with your asset management, you need to be able to do this sort of thing because you've got 2 million different things happening at the same time, or not at the same time, potentially at the same time. So again, what it looks like, just again, very quickly in here, I've got some, okay, so I've got, so let me change this one. Oh, change it to Gothenburg. Okay, so now in my without, hang on, let me take the dates off. Let's go into now. Okay. Right, so in my Gothenburg configuration, I've got three requirements in my tree. The other two are applicable to something else. Sorry, they're effective to something else. Now, if I go to doors, okay, so here I am in doors, and I've got a link to that share space, OSLC link to that share space object. Just get my mouse to work, hover over this, show one. And you can see the three things, okay? So I've got the three things there. Cool. Now, and this is a stream here in doors. So if I come back to share space, and if I actually go and edit that structure, now which one? Not remember. Speed. Altitude. Okay, so I go and edit this one, and I remove that, change the effectivity. Let's go and remove this one. So I've got an effectivity to a different object. So now I've got 4 things in there, and because we've chosen a stream in doors, when you look in the doors one, I'm not used to working without a mouse. If I go and ask for this again in doors, well, you've now got 4. So is the share space side, which is using implicit configurations, is sending to doors something that's expecting an explicit. He's asking for the latest version, and I'm actually playing around with these things. So I've got the configuration up here, which is in the share space side, it's an object effectivity. So I'm sending, or share space is interpreting the configuration sent by OSLC as an object of activity. And because it's a stream, it's now. So we've basically got the two to try and play with each other.
As nice as they
As
can.
nice as they can. And well, what we chose to do was actually purposely not to restrict either side. So we wanted to not tie down the step world to be explicit configurations. We wanted to keep that line.
So if I've understood this, is the share space server is managing the step type configuration.
Yeah.
But on the OSLC side, it's managing IBM, or it's presenting as IBM global
Yeah.
config.
Yeah.
Exactly.
Yeah.
Exactly.
Yeah. Yeah. Exactly. Yeah.
I would personally not make the distinction with baseline. For me, what you have shown, it's also a baseline, meaning activity. To select what is, to check the effectivity dates when want to observe your product at a certain date.
Dates,
for me,
yes, yes.
it is kind of
Right,
baseline.
right. But the way the OSLC works is they only make a baseline. They consciously decide, I'm gonna make a baseline now. And they can't, and they got a baseline earlier. So if I make a baseline the 1st of January and I make a baseline the 1st of February. And I go and ask for something mid-January, I will see I won't see
Early January.
the early January, you won't see. You won't see the date on that particular date. You explicitly choose which dates to make that baseline.
But isn't the word baseline has double use meaning here?
Yes,
Right,
yeah,
so I
yeah,
think
yeah,
we can-
yeah.
I mean,
Yeah,
it's like
yeah.
using-
It's different,
Talk
different.
about S baseline and H
Yeah.
baseline, because it's.
Yeah,
completely
yeah,
different words.
yeah. So anyway,
Semantics.
let's go back to the slide. So just, okay, that's the picture. So how do we do it? So what we've done is, when we create a link, I've only showed you the doors linked to share space, but we also do it the other way around. And what we do the other way around is, you create a representation in share space for that object wherever it is somewhere else. Okay, so I basically make a placeholder in share space for the requirement that's indoors.
A local configuration.
No, well, the local configuration, but actually the resource, okay? So I now have the baseline of that resource somewhere else. But I can, when I link to that resource from other things, I can then put my effectivities on it. So it's a completely different way of doing the same thing, but, doing federation, but doing it the step way. And what's really nice is you can use the OSLC approach to get that resource information within the step environment, which has effectivity between things. So it's just a completely different way of keeping the way we do things in step. You've got a resource, I'm going to create links to it with effectivities on it and object effectivities on it, which just don't exist in the step speak, and then adding this extra stuff.
So on the step side, is the share space product managing that itself, or is it just getting that? Onto?
Either. That's another conversation. So share space can basically consolidate information from multiple places.
Yeah,
That's what it's
cool, right. So it,
main selling point.
so the whole object, all that tracking could be in an enterprise resource.
Yeah.
It's a
And what-
SAP or something.
Yeah,
there.
And what gets really interesting is if you start having one resource with multiple views federated from different places onto the one resource, that's when it starts getting really mind-bending and really interesting. So I can have that on my artifact, my whatever it is, my computer, and I can have a bit of federation coming from here and something coming from there. And when we get into the digital product passport stuff that the European Union is coming up with, that's going to have all sorts of bits of information coming from all sorts of places, and you can see that was really interesting to investigate. Anyway,
And on the OSLC side, in the original definition of domains, one of them was asset management. Is that where this is presenting, or?
so that's where we use it. So we're trying to get the federation, because as I say, most of the OSLC things you see are in the requirements ALM phase,
Right.
and we're trying to use it
So you're
in
trying,
PLM onwards.
so you're trying to pioneer the asset, the original, it's been there for 10 or 15 years.
Yeah.
It's been
No one-
dead,
but no one's done anything with
inactive.
it.
Yeah.
So you're trying to pioneer that.
Yeah, we're trying to see how you can use it from the sort of PLM phases onwards, when you've got real things that are changing in your life as you go.
But what you're talking about now is the scope of the Helpful 3 project.
Yes, we're getting on to helpful
Next
3, which is what we want to do next, but that's the pictures. Excuse me. Okay,
Oh,
Is it-
no, I can take over, right? Easiest.
Yeah.
Oh,
So
maybe I'll
now-
continue.
Up to now, you saw the principles, but then you have to build the stuff.
Yeah.
To make it work, and then we hand over to Jad.
Yes, okay. No, I'll just continue, but maybe it's easier if I click the button.
you've got mouse.
Like that, I'm not using it. That's where you were, right?
Yep.
Let's see if I manage.
Oh,
Oh, okay, it is, yes. Oh, we have half an hour.
Yeah.
I'll do it quickly.
Yeah.
Okay, so I'll do it very quickly then. I mean, what you saw here in our cases, like Doors and Polarian, these are native. So if you have these two, you can just configure them and run with OSC. PTC, I understand, Siemens, IBM, they all support OSC natively, even though not many people know about it. So if you have that kind of thing, it's already in place. Jira, ShareSpace, and I mentioned something else that we've used, SharePoint. I mean, these don't come with OSC. And how do you go about that? So what we've done in this project is, that's the sort of the startup of the company I built, is to provide the tools and necessary technology to make OSC available when it's not available already, and to make it play nicely with the native tools also. And the principles are the same, connecting to the relevant data without synchronizing, etc., as a basis. The OSC that we've showed, basically. And this is sort of the links designer. It's a tool that lets you support building OSC applications when it's not supported. Two aspects. I think one is really important. I want to go through this information modeling. This is like what we start with all the time when you're modeling, connecting to this with local and global domains that we can discuss also. But let me just quickly go through this. When you talk about information modeling, I mean, in my head, there's like 3 levels really in general. You have the conceptual models. That's when we're at meetings or within your organization. What is a part? What is a component? They can mean different things. But this is just in the meetings. And then you have the lowest level when it's like inside an application. That's when you can have your UIDs and very, very detailed schemas of the applications. And these are sort of not relevant. That's internally for the tool itself, right? Mm-hmm. When we say information modeling, that's somewhere in between. I think typically I found them in these process models where you have activities and you say input and output, and there's some artifacts that come out. But these are quite generic in my experiences. They're just really good, relevant to what they do, but they're not enough. You seem to be reacting to something.
Yeah, I don't know, maybe I missed a link in this chain. The ability to identify some piece of information that's contained in one of those tools definitely requires knowledge of how that data model of that tool stores that information.
Be patient.
Yeah.
Yes,
Yeah,
yes,
yeah,
there is
yeah.
some, yes. But when you develop a tool, if you're
Just
working,
continue, because
Yes.
you come to that
Yes.
anyway.
you don't care about the outside. But this is actually a little bit what we found missing is this connection of the information when you talk about exchange of information between tools, whether it's sync or link or something. What you do. So I mean, if you take Jira, for example, the issue, if you're a developer at Jira, you really focus on the schema within the tool and you want to optimize it, and it's could be lots of fields and stuff. But no one cares about that internally. What is the data coming out of each tool to be communicated, read, or consumed by others? And there you need to define a model in between that is detailed enough so you know what you're consuming. How should my test plan look like? Exactly which properties do I have? So they should be exact enough as much as a data schema, but they should be at a higher level, only relevance for exchange of data between things. But there should be, and they're more detailed than these process models, which is more, conceptual of how you want to do activities. So we think that there's a missing link here between the high level stuff and the detail of this internal of the tool, because they're more optimized for the tool itself, not for the exchange of data.
Are you talking about the architecture management domain here?
That would be architect. Yeah, but okay, if you're thinking, you simply, I mean, in OSCE, there's something called architecture management, but that's very generic also.
Yeah, it didn't really get any interoperability because
No,
it was so undetailed that IBMs would not interoperate with PTCs, would not interoperate.
Yeah,
with-
exactly. That's like with the very generic, and that's where, so basically so I've been in the OSCE standards since 2012.
Yeah.
And core is beautiful. Those principles that I mentioned, they're really good. But when it came to the domain, requirements, test case, test quality management, they're pretty good, but they're very minimal. But there's a lot of data. I mean, if you take PLM, there's lots of rich data that doesn't fit there. Otherwise, it's become very generic.
Yeah.
So we actually built a tool. There's an open source variant of it since then to actually let you define your own domain models to be more exactly within your organization, how things should look like. And this is actually what you do. You draw this thing in the tool. And then when you produce your APIs based on that tool, you're guaranteed to match that information model you're exchanging.
So why isn't that layer just the step standard itself?
Well, you can do the step. So take the step standard and put the OSCE principles on top of it. That could be, we can build a step domain out of that, and then use those OSCE principles of web services, URLs, using the RDF technology, delegated UIs. Great.
I'm sure there are other ways, but
We-
that
we-
seemed like a reasonable way to the extent that the other tool vendors are more or less complying with the step standard.
Yeah.
They're intending to anyway.
Sure.
And so that gives you kind of a
Yeah.
We
Way to distribute
had a
out.
go.
Yeah.
We had a go we did an OSLC domain for part. The issue is that the step standards are sort of designed for data exchange, and you're expecting lots of bits to go into that one file. So you need to decide which of the bits that go in that file you want to put in this domain. So we started with part, and we decided we were going to include next assembly view usage and names and things like that. And so we decided that basically, and instead of it coming across as a step content, it came across as an OSLC style, but the next assembly view usages were effectively links. So you don't get the next assembly view usage object, you get a bunch of URLs in that field, which you then use as the next links. Anyway, we'll have a conversation.
If I translate,
Yeah.
I've worked with Step very little, but if
Yeah.
I understand it, it's so complicated. I mean, I struggled, but that's because the aim of it is to exchange data at this level. You want to put data, take out data from one internal schema and import it. So it's got all the information.
Yeah.
But if it was to be at the integration level, maybe a very subset of that would be enough just to exchange data.
Yeah.
And then you don't need the details. You can build it on Step, but you don't need all the details of Step. Just keep it at one level higher.
And then if you again go back to the original model being presented, the idea is to, within the engineering disciplines, they have very rich schemata. But between them, we want them to keep them as simple as possible.
Yeah.
So that is why we can make them small, minimum.
And it was,
And the way it's implemented internally within the development, that we don't care, because we will be interested in the traceability between them.
and to be fair to OSSC, I think that we're talking about AM, architecture management. To be fair, I mean, the best they can do is, it's just those general ones. It's hard to be more, otherwise you end up in the step track.
Yeah.
But I think without advertising too much, I mean, the idea is that you should be able to build your own domains on top of the core. And I think this is the missing contribution in OSSC, to allow more for, but then again, it's your own organization, so you do it yourself. I think the OSSC technology allows you to extend these domains in a really nice way, so it fits perfect. But yeah, I wouldn't go the step way, because that's really to exchange data so you can save it in your own schema, and that's not the right. I think that's too tight coupling, and in most cases you don't need it. But of course, step has its use, but not for these cases. Okay, I think that interesting. So anyway, based on this information model, then you can design your API, define it, and that's guaranteeing that your data you're producing and consuming is based on that information model. So we build a tool that basically, bad example because Polarion comes natively, but if you have Polarion, you go in and you drag and drop and decide what services you want to show. And there's a lot of technology in OSSC. So we abstract away that. You just model it graphically. You say, I want this kind of authentication. You press the button, and then you get your API out of the box. And then you will show you experiences. But the idea is that all these delegated UIs, what you saw in Jira, for example, is built with this technology. So it's sort of quite easy. All you need to do is decide just, the data from the system, how should I expose it in my information model, and do that little transformation. And given that it's based on that, we've made sure it's OSSC compliant, so it's out of the box going to be compliant. These are the ones we've actually tested with, but anything OSSC based should match them because it follows the standard. But you as a user of this tool don't need to care about OSSC anymore. We hide away that, but follow the principles. You did.
Yeah, so these are experiences. So we're not an OSLC house. So we had two sides of the application. The side I'm talking about now is using the tools that Jazz talking about. So what we found was OSLC core got really good stuff, okay? Really good stuff, and it's really, really useful. The OSLC domains, versioning and configuration management approaches are very different from how you do it in STEP. I'm not saying either's right, they're different for different reasons, but they are very different. And as you said, there are many optional properties, and the documentation is sometimes imprecise, and leads to very differing interpretations, which is exactly your point. Some people put the optionals in, and it's hard, there's only 2 or 3 things that are actually mandatory. So, and it was done like that for a purpose. But if you're going to do some serious integrations, you need to agree that these optional ones are maybe not optional anymore. There's that sort of thing. Okay. So we use Links Designer, and it made it very much easier to extend existing domains. So we added a few more properties onto the existing domains. We added a new domain. This is the one I said about part. We didn't try and do it seamlessly. We just created it just to prove it was possible. And I can get share a space to share a space talking with OSLC parts, which was great. And the nice thing is you only need to concentrate on the domain properties. You don't have to understand the rest. So there's a lot of stuff about authentication and getting the discovery services working and all this sort of stuff, which the tool just does for you. So what we did was, I'm an engineer, I'm not an IT person. And so basically I put our API schema into the tool, it generated all the code for me. And I just then had to say, okay, when I say next assembly view usage or whatever it was, in OSLC terms, it's called child. And I had to write little bits of Java code that basically said, go and get the child and put it into the next assembly view usage. And effectively, it was my coding abilities is fine for that. I can dabble, but I can't design anything. So it was aimed at people like me. And it was really cool. And I can basically implement a new domain in ShareSpace. We've got a very good developer on our side who made our client very easy to do as well. So I can implement a whole new domain in under a day to get ShareSpace both sides to talk. So I did that with defects, they call them in OSLC. So I used your Jira and got ShareSpace to talk defects, both server and client, which was cool.
But you got some trick.
Oh yes, I had. Well, I basically Jad and I on the first afternoon we got it to do something. We got the first service done in 3 or 4 hours or something, sitting down and getting it to work. Whereas previously, before the tool came along, it took us 6 months or something just to get all the authentication and all that sort of stuff, which was yeah. So that was a great boost. You still have to do the server side. There's not, the bit that in your application makes the links and things that you've got to do all that, but actual turning your application into the server is great. So basically it means you can link to things that don't have a front end, an internet. Anyway, development aids, there's some very useful test clients and servers. And so Jad's got some brilliant tools. Most developers use Java. So the other SDKs are not very well maintained. And I said a Links Designer makes them all redundant anyway, so you can just for developing the adapter side. Next slide.
Switch. No.
Yeah. So with Links Design, I probably said all this before. So ShareSpace itself, which is the Eurostep tool, is a configurable open architecture type of application, which made it very easy for us to use. I can actually quickly configure the schemas. What I found was it gave you much more concise code if you had a schema that only provided the bits of information you need, rather than the 500 properties you could send. So there's some little things that were we found a lot easier. So basically the configurable open architecture made it very easy for us to do. Here's my hands-on training, about 4 hours to establish the basic one. And after 6 months, I can add new services in a few hours, but if I want to do both sides, it will take me a day to do a new thing. So the basic adapter needs minimal code. As I said, I can do it. Crossing configuration paradigms, you need more experience code side. It's not just a simple, child to next assembly view usage. You've got, if you want to get the OSLC baseline and streams type thing to talk to the step object, you've got to do a lot more crossing over and things like that. It's not quite as straightforward.
No,
That's
but
not
then-
just an implementation experience, right? That's the big, you need
It-
conceptually.
Yeah,
Conceptually, the
it's
difference-
conceptually it's hard, but you do need to, there were some clever bits that our developer did that blew me away, I actually was doing.
But I mean, the thing is
yeah.
that we have Judith very well entrenched in the step world,
Yeah.
and then we had, we had Iran.
Yeah.
Who knew everything about OSLC configurations.
From IBM.
From IBM.
Yeah.
And it was like, you are doing it wrong on the other side. We started out there. And then afterwards, said, no, you're both doing it right, but it's different. So
Yeah.
it took us a long time to get down into the
Yeah.
very.
How do we
fine
play
details.
nicely without being, yeah.
But things like you said, baseline, it really meant different things for
Yeah,
different people.
yeah.
So one question, this project or Saab, or you mentioned the aircraft carriers in the UK, does anyone have this running across multiple organizations, i.e. like the British government doing one thing, handing it off to the shipyard, who's handing it off to subsystem
Pure
supplier?
research.
Yeah, so we're presenting research here.
Yeah.
You research, so,
Yeah.
So the next step is to do actual demonstrations.
yeah.
And then also to extend working with the digital passport.
Mm.
But, you know, what I want to do, with putting myself hat. We are just a small airframe. We want to get this linking capability out of the box in every tool that we buy. We want to be able to switch in and switch out. And in order for us to be able to do that, we need your support. We need you to be interested as well. So we can demonstrate things locally, but we will only have an impact if we as an end user community can get together and say, this is the way we want it. And this is also why we booked this meeting. So we have some very encouraging results. But we will accomplish very little if it's only Saab with our few aircraft that is asking for these kind of capabilities. And just to give an example, we presented our ideas to one of the big PLM vendors. And they listened very politely for about 3 quarters. And they said, I will not do the accents. They had said, we like modularity, but this is madness. And then we knew that we were onto something good. But it's, I mean, those companies, they are bigger than us. And the good thing, I think, is that with these projects, we have shown that we have a magic box that can generate the interfaces. So if those 2 vendors doesn't do it for us, we can do it ourselves.
But you want to put us out of business because you want the vendors to do it.
Yes, of course, but maybe you can sell your brilliant
Okay,
tool
sure.
to the vendors. So this is again why we are going to highlight our experience. Because we want you to request the same capabilities as we want and so.
If he puts you out of business, it's gonna take 50 years.
Yeah,
Yeah.
I'm happy to.
Yeah.
I like how those capabilities were expressed in the pyramid.
Yeah.
I guess I'm a little hesitant around OSLC and I'm also hesitant around Aerospace. Just how do they make their money? Honestly, where is that coming into play? Are they a critical part of the solution space here, or could we change them out to something else?
So, to be absolutely honest, when we created our project, I asked my friends, we want to participate. So Eurostep is an old friend. We can see Aerospace as a tool as our external collaboration interface. That would mean that the suppliers that we only trust a little bit, they will deliver in step format whatever they deliver, share space. And then we would link up to our own internal environment, because share space is step-based. So it's very good for external collaboration. And internally, we would use our internal development. But we're not using share space commercially at the moment, so I have to tell them all the time that keep on doing this, because eventually we will buy.
But OSSE doesn't depend on a tool.
Right.
That's the whole point. Yeah.
You can develop your own code for even own business applications. So you know, it's a thing. You can link what you have already with other bits and bobs, and you can link what you have basically.
Yeah, and I think, you know, going and looking at OSLC, people in the company, but not just that, just going just based on this. But you still need some of those key things. You need to know what the information structure is. You need to identify the information that you're trying to access.
Yeah.
You need to be able to connect those from multiple tools. We got chains of those connections that we want to create so that we can do these end-to-end queries. We got to configuration manage every single piece of it.
Yeah.
And manage every single instance.
And John, now
What's the alternative?
we're talking about the second aspect of the Helipad 3 project.
Of a,
Of our next project, where we want to demonstrate that we can actually navigate the structures and draw our own conclusions.
So there's a lot of, if you refer to the pyramid, I mean, it's just the basis. There's lots of problems, but if you build on those basic ideas, I think you can still. The other one is not going to be solved by that, but at least you have a good basis for building your querying and your configuration management, the impact analysis. I mean, you name it. There's a lot to do, but this is a good fundamental principles to do. Yeah.
yeah,
There's no value in OSSE traceability itself. Its value comes later. But these are, it gives you the basics.
the value isn't necessarily OSLC per se,
No,
it's those
No.
unique
No, no.
identification and known structure and
Exactly.
consistency of that structure.
Exactly. Yeah. But you can use that for some.
But still, it's the existing standard that we are aware of. And for those of you who know where I came from, I was once very much into STEP. But the application protocol I was architecting, it died. So since then, I'm a little bit STEP allergic. And the idea of having very small information domains means that you can do the standardization internally within an organization quickly, and also doing the international standardization also very quickly. And hopefully the need is still alive by the time you finalize standardization.
So, and so for both LinkSworks and Eurostat, the stuff that's been shown here today, are those commercial products that can just simply be bought? Or the IP that you use in services engagements?
I mean, we're independent commercial entities, so you have share space.
So if I want to order a share space, I can just get a.
You can always share a space, but the OSLC Federation is research.
Research. okay.
Yes. Yes.
And when it comes to Link's work, Link's Designer is a commercial product, or the actual connectors are shown, like for SharePoint. I mix share space and SharePoint, so have to be careful. For Jira, yeah. And yeah, Link's, it's not a platform, it's a tool to build your connectors, but there's no central platform.
I don't want to dominate this at all, but I definitely see value because we're all using the same tools. And to that extent, to be able to get into those tools and not have to keep recreating it.
Yeah.
I'm all for that, absolutely. We got our own internal tools as well, though, obviously.
Exactly, that's also the challenge when you have internal tools, you're gonna have to build these APIs and you can use these principles as a sounding way of doing these principles.
But as long as that tool has an API, you can wrap the adapter around it easily.
And again, these APIs are not only, but the main case for OSSE is to create traceability. There are many cases for integration. That's something else. But if you want to create a digital thread or a traceability, This is where these delegated UIs and, you know, linking, not syncing, those kind of principles could be a good basis for it. And then there's other cases.
Maybe the biggest challenge is going to be really agreeing on the methodology, because like what you're presenting is kind of federation on steroids, right? Where I think the pendulum in the configuration management world is kind of swinging the other direction, where you want to distribute the data with keeping the provenance, right? So that you know where it came from and that you know whether the data is up to date or not, right? Because ensuring that all of those different services are gonna guarantee data immutability is, in my opinion, you know, almost impossible, right? Where you refer to something as a UID, there's no guarantee that if I ask that same UID, like even if it's version aware on the OSLC side, there's no guarantee that the service that I'm asking the information from is not gonna give me a different answer tomorrow.
It will give you a different answer tomorrow.
Hmm?
It's a guarantee, we'll give you a different answer.
If it's a stream, but if it's a baseline.
If
No, well, it depends, exactly, it depends what you're asking for.
Yeah.
But if
What,
you're
what
asking
I'm,
for
what
the
I'm,
latest-
what I'm saying, right, I'm saying that I'm not asking for the latest, I'm asking for a specific configuration, there's still no guarantee that the tool is gonna provide me the same answer if I ask for the same configuration twice.
Why not? If you're asking for a specific baseline, let's say, if you say this particular version,
And if
to
it's,
simplify.
and if it's one
Well,
of peers, you know, then you're
Yeah,
you're
but
kind of stuck.
what you, I mean. In
I mean, because
in-
some
but
tools
that's-
just do not configuration manage the data that way,
No,
right?
no, no,
There's-
No, but that's always gonna be.
In the initial presentation, you might have seen that we had a small arrow for an archive. And that is inserted there because we want to make sure that we have a low-turn capability. Where we can say, we know this is stable, it's tool independent. So we can always go back to things, not in a fine granular data fashion, but in a coarse granular fashion. So you're absolutely right, Alex. And the fallback is to say, yeah, we need to have a local capability, which we can depend on.
No tires.
Long-term archive.
But you know, that's a agree with the trend this week. So I work with Lieber, a company in Vienna. It's a very small company, but they're big in system modeling. It's Sparks, and they download an integration with Java for requirements, system tool. And so they were doing the usual tracing lengths and, you know, suspected lengths and stuff. Then at the end, they actually moved the diagrams from the system tool into the requirements tool. Not just the links, they move the actual diagrams and then do exactly what you said, they have the provenance. So they can check whether the diagrams are up to date or not. Sure. But they don't just reference it. They actually move the data.
Diagrams as diagrams or diagrams as populated with
Everything.
discrete items.
Yeah, so the diagrams that are referenced by the requirements tool, the whole diagram moves into. the
When you say move, you mean there's a copy, not a move.
Copy.
Yeah, that's not.
But
Yeah,
you
that's
you
copy,
are,
Yeah.
the downside of that one is that you are relying on that other tool to provide the agreed access rights to that information you've given them.
Yeah, you duplicated them all.
You've duplicated and you've given away your access rights.
Yeah, but you're not
But you're
dependent on.
trusting them to do something.
Yeah, but you're not dependent on the IT access to be
Yeah.
working when you
Yeah,
see
yeah.
the diagram,
Yeah,
right?
But they are dependent on the connection to get that data out. I mean, if you break the internet, it's gonna stop working, right?
Yeah,
There's
But we are not saying in any way. This is the only way to do migrations. We're saying, no, this is a very capable way of doing integration.
and I didn't say I agree, I just observing what Alec was just saying.
Yeah.
You know, the trend I'm seeing in the marketplace is actually to consolidate, keep the data, keep track of where the data came from, but actually.
No.
But then, if you move it, the first step is already right, and you do it the second step, the third step, things get.
I don't say I endorse it, but.
Yeah, and they have an interest in consolidating, you said the word, because they want the business, I mean, like, so I do some consultancy for Polarion. for
Yeah,
example.
right.
They have really good connection, but it goes one way.
Yeah.
Look, we can synchronize your data into our
Yeah,
system.
then what I'm
Of course, there's an interest. in
everybody
that.
would like to suck up the other guy's data.
Of course. It doesn't mean it's the right way for, as an end user.
The other thing about the OSLC is when you do a get.
Yeah.
There's nothing to stop you storing that data.
Yeah.
Now, the OSLC way is to not store that data.
Yeah.
And every time you go and get it, but there's no reason why you can't see that. If that's what your tool decides, but then you do have to own that data and put the right access rights and whatever else on top of it. So that's just the one of the interesting things about it is if I create that link and then Jad goes and looks at it and he hasn't got permission to look at it, he won't be able to see the data.
Yeah.
Because the other tool is managing, the tool who owns that data is managing the access.
And the other use case, I have a very, very large government client from a government who's very interested in federated assurance cases.
Okay,
So the problem they have with PLM systems is the PLM systems become enormous filing cabinets of stale PDFs. And they can't trust that the PDFs and the PLM systems have any correlation with reality anymore after 5 years. And so they are aware of OSLC, but they don't want to query one object at a time.
no,
They want to say, okay, that test you did, or send me the whole report.
But there is in OSSC something called TRS, Tracked Resource Set,
Yeah.
that complements, I mean, when we market pure OSSC, it's about linking, the syncing, but in OSSC, there is a thing about copying, but you do it the OSSC way.
Right.
So that's worth looking at.
Yeah.
Tracked Resource Set, which is implemented by IBM Engineering Insight.
Yeah, because they want to get whole evidence sets.
Yeah.
Not objects, even interpreted
Yeah.
evidence sets.
and another thing we were.
Engineering Insight would be in the tool.
Yes.
We were looking at, again, for this Helical 3 Mystic project, I think on next. One of the other things we were thinking about was that it was sort of data investigation. You know, how do you get these services to go and, if you're going to do some AI,